Hi everyone and welcome back to another lab. In this lab, I will configure and verify extended ACLs on Cisco devices, which allows to filter based on source and destination IP addresses, protocol types, and port numbers. This lab will demonstrate how to configure both numbered and named extended ACLs and apply them to router interfaces and verify their operation. And as always, I will start by explaining what extended ACLs are, how they work, and where they are typically used in real-world networks. Then I will go over the lab topology and objectives to give you a clear understanding of what we are tackling. Next, I will go through the lab tasks step by step, and finally I will guide you through the configuration process and explaining key commands along the way. By the end of this lab, you will have a solid understanding of how to implement extended ACLs. Okay, so an extended access list is a powerful filtering mechanism used in networking to control traffic flow based on multiple criteria. Unlike standard ACLs, which only filter traffic based on source IP addresses, extended ACLs allow administrators to specify both source and destination IP addresses, as well as transport layer protocol like TCP or UDP, and even specific port numbers. This makes them highly versatile for enforcing security policies, restricting access to certain services, and optimizing network performance. Extended ACLs work by evaluating packets against a set of rules in a sequential manner. When a packet enters or exits an interface, the ACL checks each rule from top to bottom until it finds a match. If a match is found, the action associated with that rule, either permitting or denying the packet, is applied. If no match is found, the packet is implicitly denied by default. So because extended ACLs can filter traffic at both layer 3 and layer 4, they provide fine-grained control over which types of communication are allowed or blocked. The need for extended ACLs arises from the growing complexity of networks and the increasing demand for security. In environments where multiple applications and services are running, it's important to allow only necessary traffic while blocking unauthorized access. For example, an extended ACL can be used to permit web traffic, HTTP or HTTPS, to a particular server while blocking all other type of communication, such as ICMP or FTP. It can also be used to restrict access to specific devices based on protocols, such as allowing only SSH access to a network management system while denying all other remote logging methods. By using extended ACLs strategically, network administrators can enhance security and control bandwidth usage and ensure compliance with the organizational policies. Okay, so regarding the lab topology, as you can see on the screen, we have a couple of routers. Both routers are running OSPF, operating in area 0. Each router advertises all its local networks, and that allows all end hosts to communicate with each other. So connected to router 1, we have 3 different departments. So PC1 belongs to the IT department and part of VLAN 10. PC2 belongs to the finance department and in VLAN 20. And finally, PC3 is in the engineering department and in VLAN 30. All of these PCs are connected to switch 1, which is then linked to router 1. And we are using the router on a stick approach for this topology. And at the top of the topology, you will see 3 servers connected behind switch 2. So we have server A, web server, and FTP server, and all these servers are connected to switch 2. And the goal of this lab is to implement extended ACLs to enforce security policies that aligns with the lab objectives. So regarding the lab tasks, we will start by testing connectivity between all end devices, just to make sure that we have reachability and connectivity between all end devices. After that, we will then restrict traffic from the IT department to server A, such that it uses only ICMP, so any other traffic should be blocked, and we will also test this accordingly. Next, we will only allow HTTP access to the web server, and then after that, we will restrict access to the FTP server using FTP protocol, and then next, we will block communication between the finance and the engineering departments. And finally, we will then verify our configurations and check if our ACL's policies works. Once we have confirmed this, we will then save our configurations, and that will be the end of our lab. Okay, so before we proceed to the lab solution, if you would like to test your knowledge on this topic, you will find a post linked in the video description below. The post includes lab information and a couple of packet tracer labs that you can download, and they are provided in a Microsoft document. You can download the document to access both the pre and the post lab versions. Okay, so I'm going to tackle the first task where we need to check connectivity between all departments and ensure that each department can reach all other servers. So I'm going to start with PC1 and I'm going to initiate a ping request to 10.10.20.10. Brilliant, we have connectivity. I'm going to test that with PC3. Again, there is connectivity and reachability between PC1 and PC3. Next, I'm going to test connectivity to server A. So I'm going to say ping 10.1.1.2. Again, we can reach server A. Next, I'll try to ping FTP server. And finally, I will ping the web server as well. Okay, brilliant. So we have connectivity and reachability between the IT department and all other departments, and that includes also the servers within the topology. So what I'm going to do next, I'm going to do the same for PC2 and PC3, and I will fast forward the following. Again, PC2 is able to communicate with all end devices within our topology. I will do the same thing for PC3. Okay, so with that being done, we can confirm that step 1 was successful, and we will move to step number 2, where we need to restrict VLAN 10 to access server A such that only ICMP traffic that is allowed and any other traffic should be blocked. We will do that using a numbered ACL, and we also need to apply the ACL against the interface that is connected to router 2, since router 2 is connected to server A. Applying the ACL in the outbound direction means that the filtering will happen as traffic leaves the router towards server A. This approach ensures that any packet leaves gig Ethernet 0/0/0 is checked against the ACL before being forwarded. So what I will need to do, I will need to go back to my topology and go to router 1. And I will try to go to the CLI, and from there I'm going to say enable to go to user privilege mode, and then I'm going to say configure terminal to go to global configuration mode. And then from here, I'm going to say IP access list. We need to specify extended. And if we question mark that, we will have two options. We either can use the named approach, or we can use a number from 100 to 199. In my case, I'm going to use 101. And then what I will do, I will say permit ICMP, and then I'm going to specify the source network, which is going to be 10.10.10.0. And then I will need to specify the wildcard mask for that network, which is going to be 0.0.0.255. I will then set this to a particular host, since we are only interested in tackling server A, and we know server A has an IP address of 10.1.1.2. So I'll say host 10.1.1.2, and then I will hit enter, and then I will exit the ACL configurations, and then after that we would need then to apply that ACL in the outbound interface under gig Ethernet 0/0/0. So I would say interface gig Ethernet 0/0/0 IP access group 101, and we would be using the out command for the outbound option, and then I'm going to hit end. And now let's verify this and perform some in-flight checks. So the first command that I want to tackle is show IP. access list 101. You can see that we have created the permit statement. And after this permit statement, there is a default hidden statement, which is deny any. Next, I want to make sure that the ACL has been applied in the outbound direction under interface gig Ethernet 0/0/0. So I'll say show running pipe section 0/0/0, and you will be able to see that the ACL has been applied in the outbound direction. Okay, so what I'm going to do next, I will try to verify our configurations by going back to PC1 and PC2 and PC3 and try to initiate a ping request to generate some ICMP packets and see if the ACL is going to work or not. So I will go back to PC1. And in here, I should say ping 10.1.1.2. The ping should be successful, and the ping is successful. Next, I will go to PC2 and repeat the same thing. So I'm going to say 10.1.1.2. And by the way, the ping should fail at this point since we're only permitting the IT department. And as you can see, the ping has failed and PC2 is no longer able to reach server A. I'll do the same thing for PC3. Brilliant. As you can see that PC2 and PC3 are no longer able to reach server A. And also I want to go the extra mile with you. I'm going to go back to PC1 and in here I'm going to go to the web browser and I'll try to HTTP to 10.1.1.2. And as you can see, the request has timed out and we can't reach server A via HTTP request. Okay, so I'm going to go back to the CLI or to the command prompt. And then what we're going to do next, we will jump into step number 3, where we need to allow HTTP access to the web server. So we need to permit only HTTP traffic, which uses port 80 from all PCs to the web server, while denying all other protocols. So again, I'm going to go back to router 1. And in here, I will go back to global config. And in order for us to achieve this, we will need to update the extended list to permit traffic going to the web server using HTTP protocol. So I'll say IP access list extended 101, and I'm going to say permit TCP any, since we want any device from all departments to be able to communicate with that server using HTTP. And I'm going to specify the host with the IP address that is associated to the web server. So I will say 10.3.3.2, and we will also include the equal sign and specify port 80. And then I will hit enter. And at this point, let's just do some in-flight checks. So I'll say show IP access list 101, and you can see that we have permitted traffic from any of the departments to be able to reach the web server using the HTTP protocol. Okay, so what I will do next, I will go to PC1 and I will try to reach the web server via ICMP. So I'm going to try to ping it. So I'll say 10.3.3.2. And as you can see, we are no longer able to reach the web server using ICMP protocol. However, if I go to the web browser and try to HTTP to 10.3.3.2, we can see that we have access to the web server via HTTP protocol since we have received an HTTP response from the server. I will do the same thing for PC2 and PC3, but I will fast forward this. Again, we can't reach the server from PC2 using the ICMP protocol. Again, we have reachability via the HTTP protocol. And again, we can confirm that PC3 is able to reach the web server using HTTP protocol. Okay, so what I'm going to do next, we will need to jump into step number 4, where we need to restrict FTP access to the FTP server, which means we are only allowing FTP traffic from all PCs to the FTP server. And one of the things that I wanted to highlight, if you are using a passive FTP, then you will need to permit a range of ports starting from 1024 going up to 65,535. I will demonstrate that in the lab. So again, I will need to go back to router 1. And from here, I will go back to my access list that I just created. So I'm going to say configure terminal. And here I will say IP access list extended 101. And I'm going to permit TCP any host, and I'm going to specify the FTP server IP address, which is 10.2.2.2. We will say EQ, and I'm going to specify the port number, which is going to be 20. And I will up arrow this and I will change the port number from 20 to 21. Next, since I'm using a passive FTP, then I will need to allow certain ports. So I'm going to say permit TCP any host 10.2.2.2. And we're going to use the command range, and then we would need to specify the range for the starting port and the ending port. So I'm going to say 10.24, and that is going to be all the way to 65,535. Okay, so one of the things that I wanted to highlight is that port 21 is used for authentication and issuing commands, whereas port 20 is used for file transfers and directory listings in active FTP mode. And as I mentioned earlier, if your FTP server is using passive mode, it dynamically assigns random ports for data transfer instead of using port 20. And in this case, you must allow a range of ephemeral ports that the server uses. And some FTP servers allow configuring the passive port range, which can help in refining ACL rules. So what I'm going to do next, I will perform some in-flight checks. So I will hit end, and I'm going to say show IP access list 101. And as you can see, we have configured the last 3 ACLs under 101 extended ACL. Okay, so I'm going to jump into PC1 and try to reach that server again. So I'm going to say ping 10.2.2.2. And you can see that we are unable to ping that server. And again, if I go to the web browser and try to HTTP to it, so I'll say 10.2.2.2. As you can see from the screen, we were unable to reach to that server via HTTP traffic. So now at this point, let's go ahead and test the FTP services. So I'm going to close this. And what I will do, I will create a text file called iee.txt. So I'm going to go to the text editor icon here. And I'm going to say this is a test. And I'm going to copy that multiple times. And then I'm going to close it. And here there is a warning message where it allows me then to save the file. So I'm going to save. And here I'm going to say iee.txt. I will then hit OK. And remember that I've created that file on PC1. What I'm going to do next, I'm going to go back to the command prompt. And from here, I should be able to list the local directory to just verify that my file actually exists. So I'm going to say dir. And you can see that we just created that file. And at this point, we should be able to test connectivity to the FTP server using the FTP command. And we are going to issue the IP address associated to that server. So we will say 10.2.2.2. And I'm going to hit enter. It will ask for credentials. The credentials are simple. It's just all lowercase, Cisco, and the password is going to be Cisco all lowercase as well. Now you can see that we are able to reach the FTP server from PC1. Next, what I want to do, I want to list all the files that are in that server. So I will say dir, and you can see all files have been listed accordingly. Now, what happens if I want then to transfer the file iee.txt that we just created into the server? So what I will do, I will issue the put command, and I'm going to specify the name of the file, which is iee.txt. And you can see that the file has been copied successfully. If I issue the dir again, you can see here that this is the file that we have just transferred over to the server. Okay, so at this point, we have reached the end of step number 4. I'm going to go to step number 5, where we need to block communication between the finance and the engineering departments. But first, we would need to determine which interface is connected to switch 1. And in order for us to do that, I would need to go back to router 1 and do some investigation. So I'll go back to router 1. And from here, I will say show IP interface brief based on the output that we can see on the screen. Ethernet 0/0/1.10 is connected to VLAN 10, and .20 is connected to VLAN 20, and .30 is connected to VLAN 30. Okay, so with that being said, let's go ahead and create a ACL and deny both the finance and the engineering department's networks, and we will apply this ACL into gig Ethernet 0/0/1.20 and gig Ethernet 0/0/1.30 interfaces in the inbound direction. So I'm going to go back to global config, and here I'm going to say IP access list extended, and I'm going to give it the name of VLAN 20 underscore VLAN 30 underscore block. And I'm going to say deny IP 10.10.20.0, and obviously we are using the network address for that department, and we would need to use the wildcard mask for that department as well, which is going to be 0.0.0.255, and then we would need to set the destination network, which is going to be 10.10.30.0. I will also need to include the wildcard mask for that network, and again is going to be 0.0.0.255. So what we have done so far, we have denied the traffic coming from the finance department going to the engineering department. Now we need to do the other direction. So we would need to deny traffic going from the engineering department to the finance department. So I would need to say deny IP 10.10.30.0, 0.0.0.255, and the destination network is going to be 10.10.20.0, and the wildcard is 0.0.0.255. I will then hit enter, and then we would say permit any, or I should say IP any. So at this point, we have created the access list, and you can see that we have explicitly denied communication between the engineering department and the finance department. So now we would need to then apply this ACL into the inbound direction under interface gig Ethernet 0/0/1.20 and .30. So I would say exit, and here I'm going to say interface gig Ethernet 0/0/1.20. I would say IP access group. I will actually copy this, and we would need to apply in the inbound direction. I will up arrow this, and I'll just change the sub interface from 20 to 30, and I will just reapply the same command for the ACL. So let's perform our in-flight checks. So I'm going to say show IP access lists, and then I'm going to include the name of the access list. You can see that we are permitting the IP any to any, and we only denying communication or IP communication between the finance department and the engineering department. Next, we will need to verify our configurations. So I'm going to go back to PC1. And actually I would need to exit from the FTP, or actually quit. And in here I would say ping 10.10.20.10. Let's just make sure that we have reachability and connectivity between PC1 and PC2 and PC3. And I'm going to say ping 10.10.30.10. So the IT department is able to reach the engineering department as well as the finance department. Now let's go to PC2 and try to reach PC3. So first of all, I will say ping 10.10.10.10. This is successful. We are able to reach the IT department, which is good. This is what we want. However, when we try to ping PC3, this ping should fail. And as you can see on the screen, the ping has failed accordingly. Okay, so that's it folks for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.